So, after your impact strength, the next properties is ductility. So, ductility is the capacity of a material to undergo deformation under tension without rupture. It means it is a measure of a material's ability to undergo significant plastic deformation before the rupture or before the breaking of the material, which may be expressed as percent of elongation or percent area reduction from a tensile test. It is called the ductility of a material. It defines the percent elongation and percent area reduction, or it is often characterized by a material's ability to be stressed into a wire. It is called a ductility of a material, or it is a very important properties of a material. So, your next is the malleability. Malleability is a similar property, that is a material's ability to deform under compressive stress. But ductility is your ability to deform under the tensile stress. The only point is difference about ductility and the malleability, that is, it is deformed under tensile stress, that is ductility, and the malleability is known as the deform under compressive stress. So, malleability is like to be formed by hammering, rolling, and it is the deformation under compression without rupture or without breaking the material. It is often characterized by the material's ability to form a thin sheet by hammering. When we are hammering a sheet or a thin sheet, the properties of that sheet is called malleability. Or when we are rolling of a thin sheet, the properties of that material is called malleability material of that thin sheet. Both of these mechanical properties are accept of plasticity and the extent to which a solid material can be plastically deformed without fracture. Also, these material properties are dependent temperature and pressure. Both of ductility and the malleability is depends upon the temperature and the pressure of the material. Next one is your brittleness. We know that what is brittleness. It is defined as a tendency to fracture without deformation, and it is opposite to ductility and malleability. So a material is brittle if when subjected to stress, it breaks with little elastic deformation and without significant plastic deformation. Brittle materials relatively have the little energy prior to fracture, even those of in high strength. Breaking is often accompanied by a snapping sound. Brittle materials include most ceramic also, most glasses material also, some polymers also, some polystyrene also. Many steels became brittle at low temperature depending on their composition and processing. So this brittle properties, it mostly depends on the composition and the processing of a material. It is all about the brittleness of the material. So next is your hardness. What is hardness? The hardness of the material depends upon the type of bonding forces between atoms, ions or molecules and increases the strength with the magnitude of the forces. It means hardness is a measure of the resistance to localized plastic deformation induced by either mechanical indentation or abrasion. Some materials are harder than others, like your plastic or wood. Macroscopic hardness is generally characterized by strong intermolecular bonds, that is called the bonding forces between the atoms, ions or molecules. It is called intermolecular bonds. But the behavior of solid materials under force is complex. So there are different measurements of hardness, that is scratch hardness, indentation hardness and rebound hardness. But hardness is dependent on ductility, elasticity, stiffness, plasticity of the material, strain of the material, strength of the materials, toughness of the materials, also the viscosity of the materials. It all depends upon the elastic limit, stiffness, plasticity, etc. Hardness depends upon the. Next one is your fatigue. What is fatigue? It is a new word for all the students. That is, what is fatigue? Fatigue is a phenomenon where structures fail when subjected to a cyclic load. This type of structural damage occurs even when the experienced stress range is far below the static material strength. Fatigue is the most common source behind failures of mechanical structure. It means fatigue is the weakening of a material caused by cyclic loading that results in progressive and localized structure damage and the growth of the cracks. Once a fatigue crack has initiated, each loading cycle will grow the crack a small amount or growing gradually, typically producing striations on some parts of the fracture surfaces, and the crack will continue to grow until it reaches a critical size, which occurs when the stress intensity factor of the crack exceeds the fracture toughness of the material, or producing rapid propagation and typically complete fracture of the structure. So basically the fatigue depends upon the toughness of the material or the stress intensity of the material. The next one is your creep. What is creep? Creep is the tendency of a solid material to move slowly or deform permanently under the influence of persistent mechanical stresses. It can occur as a result of long-term exposure to high levels of stress that are still below the yield strength of the material. It means it is the tendency of a solid material to move slowly or deform permanently under the influence mechanical stresses. The creep is also called as cold flow, and it can occur as a long-term exposure to high levels of stress. And the rate of deformation that is the creep is handling is a function of the material's properties, exposure time, exposure temperature, and the applied structural load of the material. It depends upon these four. The first one is material properties, second one is exposure time, third one is exposure temperature, and the last one is your structural load of the material. So depending on the magnitude of the applied stress and its duration, the deformation may become so large that a component can no longer perform its function. So in your creep properties, your example, creep of a turbine blade could cause the blade to contact the casing, resulting in the failure of the blade. So creep is usually concerned to engineers and metallurgists when evaluating components that operate under high stress and high temperature. It is all about the creep properties of a material. So it is all about the mechanical properties of a material. Next one is the second one is your physical properties. And the physical properties denotes as describe the response of a material to imposed stimuli under condition in which external forces are not concerned. And the physical properties include these properties like your dimension of the material, color of the material, melting point of the material, structure of the material, appearance of the material, density of the material, and the porosity of the material. Those are the physical properties of a material. Every material have their own properties like your mechanical, physical, and those are different to each other.